Hello, everyone. My name is Umar Hayat, and thank you for this opportunity for talking to this forum. It is a great job which is done by the IvorySQL team. That they, it takes a lot of effort to arrange such an event. So let me start with my introduction. So my name is Umar Hayat, and I'm a software engineer and right now working in Sky Worldwide. Previously, the company name was Bit9. So my main interests are like I mostly work in PostgreSQL based software, PostgreSQL itself for the RDB maze. On the graph side, I mostly work with the Agents Graph and Apache AGE. And on the high availability product, mostly I do contribution, open source contribution in PG Pool. I'm from Pakistan, but currently from last 4 years, I'm living in South Korea in Seoul. So that's me. And about this topic today and why I selected this topic is that this the graph is quite after the in last few years there is a lot of focus on graph because of AI. So in this talk I will cover some past, some the present situation of the graph development and the future direction of the graph ecosystem, especially in PG. Of course, there are a lot of other vendors, a lot of other databases which develop the graph solutions, graph databases, graph tools. But current focus for today is mostly the history and the present and future situation of the only the graph ecosystem in PostgreSQL. So I will just focus on that. So let's start with the past. So how it started. So in 2017, the Bit9 started a project with the name of Agents Graph. So what they did is they created an open source. They forked the create a fork of PostgreSQL and tried to implement. They have multiple. They were already doing the R&D on this implementation. How to store the graph data and do all the operations which a graph database need, a graph application need inside a relational database. So this was kind of early proof how to in store the graph inside the PostgreSQL, and it should behave like a graph database. Of course, we can query different tables and assume, like using the CTEs, that this is a graph behavior. But to mimic properly a graph behavior, storage, different operations, what they did is they created this agents graph. So it is a fork of PostgreSQL, but specialized in the graph databases. And SAM is not only the storage, but the upper layer as well. Like if you see the syntax, the syntax of graph database, graph query is a bit different in Agents Graph. So instead of along with the SQL, it also support the Cipher queries. So this is started by 2017. Actually, it started a bit early, but 2017 was the first release of this Agents Graph. Now, if you see how does it look like I'm not going into too much detail how what about the relation, how the graph data represent. Probably you already have different talks, and it's been almost 10 years. These kind of databases, or maybe 20 years. These kind of databases are already in the market, so everybody know what are different relation between different entities. And so I'm focused on how these entities are implemented in Agents Graph. So let's see if this is an example of Agents Graph query. And you see this syntax is like what we call Cipher syntax. And there is a standard previously that with the name OpenCipher. So if you see this query, it create a graph with the name people, and it create one label as a vertex, and there is another label name with nose. So if you want to query if you insert the data that you insert multiple person data into with the label name person, and then you if one person know the second person, then you will be then you would be adding relation between them, that this person Umar knows this second person. So let's say if you have a lot of data, and if you want to query that data, what would you do is, in the cipher syntax, you would write this query, which is match query. Instead of like you have a similar query in RDBMS, which is select query to fetch the data, to retrieve the data. In Cypher, there is a match query, and you see there is a person A with the name Umar, and if he knows person B, and return all the name with person A and B. So this is how you query a graph database. So this is a quite simple format how we can retrieve the graph data from a graph database. Now let's say fast forward after a few years in 2019, because this was a previously agents graph is a fork, and there was an idea, why not create an extension of this agents graph fork. And the Bit9 did a basic research, and they gave they donated the code to Apache AGE Foundation. So in 2019, this Apache AGE with the proper noun R graph extension, which means Apache AGE, started the incubation in 2019. And there was further development in this project, and in 2022 it was graduated to a top level project. So now Apache AG is a top level project from Apache Foundation, and currently it is the whole governance system is based on Apache. So it also support the cipher syntax, which agents graph also support. And of course, you can combine, same as agents graph, where you can combine the cipher queries with the relational RDBMS queries. You can also write a hybrid query in Apache AGE as well. So let's say if we take an example that this is like, for example, because this is an extension, so most of the people know that we cannot change the right now we cannot, I mean, there is no pluggable or extension level support that we can change the query syntax at the grammar level. So what this AGE does is, it provides multiple function, and all the cipher queries are also executed like a user defined function. So to create a graph, you just call a function create graph with the name people. And if you want to create v labels, your vertex label or edge label, you can create using these functions like create v label or create e labels. And then you will insert the data like using the create clause or using the merge clause. And then if you want to retrieve, you would be using the simple RDBMS select statement. But in the from clause, there is a special function which is cipher function. Now this cipher function, inside this cipher function, you mention your graph name, and then as a second parameter, you can mention a full cipher query. Like if you see the same thing what we did in agents graph, if you see here this query, it is doing exactly the same thing. There is a match person A with person B, and the person A, his name is Umar, and whether he knows any person or not, and then return the person, all the friends of the person Umar. So this is an example how you write a simplest cipher query to create a graph and then retrieve the data out of that graph. So this was this was done. I mean, there are multiple releases. Currently, it support PG16 AGE. So there is a current ongoing development happening in this project as well. Now, if you see the present, or maybe not the exactly present, these couple of years, you will see they were in last few years, there were a lot of graph standards. Okay, how it will affect the next ongoing development, I will tell you later. So if you see, a few years ago there were a lot of different bodies which were working on different graph implementation. There are different database available which use different syntax for the graph data. And but recently, the most famous, there were two standards from the international standard body which are surfaced, which are released in last 2 years, which is in 2023 and 2024. One was SQL PGQ and the other was GQL. So I will tell you a little bit detail about them. So if you see, the first one is the which is released in 2023 is SQL PGQ. So it is mostly the main purpose of this. The first standard was that to the people who already are familiar with the SQL language, how they can use the graph query, graph syntax inside the SQL language, or the other purpose is like you already have existing data in RDBMS. How can you treat the same RDBMS data, RDBMS table as a graph data? So that was the first one. And the second standard, which was released in 2024, was GQL, where a lot of vendors and researcher and community had a lot of collaboration, and they come up with the language, the proper graph language, which is native graph language. What you can say that is a native graph language, because the purpose is not much compatibility with SQL, but defining the language itself for the graph query. Now, if you see the GQL, and if there is already existing language which is SQL, and now there is this GQL. So if you see, you will see the syntax of SQL PGQ is kind of mix of both standard or both languages. So let's go on a bit detail. So this is the graph query language, SQL PGQ, which was a relational. It's kind of extension of SQL, and it can combine the existing SQL knowledge. You can combine the existing SQL knowledge, and you can use graph queries along with that. So let's say if we take an example, how does it look like? I mean, you already know how to create the table, how to query different relational tables. So let's say if you already have these two tables on the left, which is one table is person, it's a just normal RDBMS relational table. It's just a person. Another table is like nose. Okay, normally in RDBMS we have this kind of table to store the foreign relationship. So if you want to create a graph, then on the right side, if you see, there is a create property graph, and that graph name is people. What exactly it is doing is it just mapping different tables, existing table with this graph schema. And the first is like vertex table, that should be a table with the name vertex, and it has property, the same property which the person table has. Of course, you can pick few properties or maybe even leave few properties as well. Another table is like nose table. Now this is an edge. Okay, the first is the vertex, which is person, and the edge label is the nose. And if you see, it is also referring to that table. So to query this database, is this graph, the graph we just created with the name people. How would you do it? Is that you use a select command like SQL, and then from graph table you can mention which graph you want to query, and then you have a match syntax. Now this is a similar like Cypher syntax inside a from clause. So then you have a match clause. There's a bit of syntactic difference. Like for example, in Cypher you use a colon person, but here in this syntax you use match a is a person, where a's name is Umar and e is noun, which is relationship table, and then the relationship label, and then it knows the second person, and the column is what you return from this from table. So the column is b dot b name as name. So this is how you treat the relational database table as graph tables, and you will see it's not exactly similar to graph queries like Cypher, but still it do the job, that you can use the existing table and the data in the form of graph. The other standard was GQL, which is mostly totally focused on the graph query language, which is aside from the SQL, and it was released in 2024. And if you see, there is a if you want to see the syntax of this GQL, there is what you can do is, you can create a graph type, and you can define a schema, and based on that schema you can create multiple graph. So the first is you can define a graph type, like for example this graph should have these kind of vertices, these kind of edges, or these kind of labels. I mean, both of them are labeled, the vertex label or the edge label. And then based on that people type, we created a graph with the name people. Now, how to query the data is kind of similar again. From people, that's the graph name, and then match a person where person name is Umar, and then knows a second person, and return second person name, which are friend's name. So if you see this GQL, this is exactly same syntax, not exactly 90% same syntax which we use for in agents graph as well, or maybe in AGE as well. So the GQL, the agents graph is, and agents graph and other, a lot of other databases already compliant on these specific clauses with the OpenCipher is compliant with the GQL. Of course, OpenCipher has few more clauses which are not part of the OpenCipher, and of course GQL also have a lot of new clauses, standard clauses which are not part of agents graph or other databases which are right now in development. So so who's implementing in this GQL standard is like agents graph is already started developing this GQL standard clauses inside agents graph existing open on the top of agents graph, OpenCipher. So what's the future look like? If you see, the first thing is the relevance with the AI, that I mean, the graph is around for so many years, maybe not in years, in so many decades, but it is already used in different analytical purposes. But if you see in last couple of years, because of the large LLMs and the generative AI, it has a lot more focus to improve the result. So previously it was only used to store those kind of graph data and do analytics, some fraud detection. There are a lot of other use cases which are already there. But now you can improve the graph AI result. You can create knowledge graphs. You can do the reasoning. It can provide a context to the response which AI is generating. So because of this connected nature of this this data representation, there are so many usage of AI. Especially you will see almost every the graph is providing the SDKs to create the graph flag, and to if you want to retrieve argument from vector database, you can do the similar thing with the graph as well. And also, not only, it's not like that you will it's not that you will you have to use them separately, like vector rack is totally different and graph rack. You can even combine them. Even if you see like agents graph, you can store the graph data in agents graph, and its properties can be vector embeddings, and you can create the vector indexes on those properties. And of course, you can also create graph indexes which are for the graph node retrieval on the graph nodes itself. So what you can do is you can combine two vector indexes. So it provides more power and more. It can create more efficiency for the data retrieval. So what's next on this graph sport in PostgreSQL is that, of course, the graph development is already SQL PGQ, which is the graph implementation of in PostgreSQL native. There are already patches there submitted by Peter Zentras and Ashutosh, I guess, is working. Both of them are working on Postgres community. The patches are already there, submitted last year. They are, the community is fine tuning them. And hopefully, of course, right now it is already PostgreSQL beta 1 is already out. So it's not possible to release SQL PGQ support in this PG 18. But hopefully in next version of PG 19, the graph support would be there in native PostgreSQL as well. And similarly, if you see the compliance because Agents Graph is more aligned with the graph databases and is already supporting the OpenCipher. So the next step is to support the GQL compliance. So which is the development is already in progress. Of course, a lot of more things need to be done. Like it need to be the graph queries, if they are implemented on top of the relational database, they need to be enhanced, and especially the query planning and query tuning, so that we can enhance the performance. And how to use more better indexing model to speed up this hybrid nature of this data on in the relational database as a graph database. And still there are a lot of tools need to be developed. The existing tools, different visualization tool, analytical tool, they need to be get more maturity in this area. So yeah, so in summary, there are multiple projects right now, namely in in Postgres database, which is first one was Agents Graph, the second one is Apache AGE, and then now the native graph implementation is already in progress. So the question is, which if you see, one of them is the fork of PostgreSQL. One of them is the second one is an extension of PostgreSQL, and now the Postgres also have going to have a native implementation. Now the question is which is better? Okay, of course, all of them have their own use cases. The fork, if it is a fork, like Agents Graph is a fork, it provide more graph-like syntax, and people who are more, it is for people who are in the graph analytics and graph user, it's more convenient for them. But of course, it has high maintenance to to support the fork. But on the other side, the Apache AG is an extension. It is more convenient to use that extension. You can use that extension on an existing project, which a server which is already running, and you can just install that extension. Same is for the native support of SQL PGQ, unless unless the PostgreSQL provides some extension and hooks to change the syntax. Of course, there would be some limitation. The people who don't want to use the SQL-like format, they want to use pure SQL graph syntax, they have to use either the Agents Graph or AGE. But people who are already familiar with the SQL, they would of course prefer the Postgres native. And on the Postgres native implementation of graph, this is just a start. There is a lot of things that need to be implemented, especially on the performance side, and different operation and graph traversal algorithm that need to be implemented. So there is it would take some time to develop those feature inside the core database, and which already, most of those things are already available in Agents Graph and Apache AG. The other thing is, this is the first version of SQL ISO GQL and SQL PGQ. Of course, the standard would also will be evolved over the year, and of course, it will add more clarity. The good thing is now these have the standards. Because of these standard, there's more more work on different databases. Now this is a standardized way to implement different things. So there would be a lot of intercompatibility between different databases and tools. So hopefully it will increase the adoption, graph database adoption in future. And the last one is, as you already seen there, I guess if I remember correctly, there is already a talk even in this conference about the graph rag as well. So you will see the graph rag and graph related graph usage in AI so much. So hopefully it will increase in future. So, and of course, whether it's a fork and extension, every these projects have their pros and cons. Like for example, if you see, there are so many examples you can see. Like for example, there is an extension for Oracle compatibility or IFCE, but still we have IvorySQL, we have EDB EPAS, we have from Sky Worldwide, we have Agent SQL. So these are the forks, but still there are some limitation in extension. Similarly, if you see the TDE, there are extension for TDE, but still different database, even Agent SQL or EDB EBAS, they provide a native fork-based implementation of that TDE. Of fork, sometime it's better. Sometime in different workflows, extensions are better, and sometime the forks are better than extension. So it depends on the use cases. And with that one, I will summarize this. This is the whole summary of this presentation. So if you have any question, please reach out to me. You can ask in the question and answer session. And yeah, if you want to discuss anything related to graph in different projects, I myself is involved in Agent Graph project as well as in Apache AGE, and hopefully I will try to provide different reviews or try to get involved in Postgres native graph implementation as well. So if you want to discuss anything related to graph, its implementation, or anything related to PostgreSQL, we can discuss this as well. So thank you very much for attending this session. So have a good day. Bye bye.